Hello everyone. In this video, let us solve one video numerical problem based on divergence computation. Now we have three subdivisions in this question where we are asked to find divergence of this vector D given. And after finding divergence, we are supposed to find the value of the divergence at the point given. So first subdivision is with respect to rectangular system, second is cylindrical system, and third is spherical system. Let us start doing one by one. We can recall the formula for divergence in rectangular, cylindrical, and spherical system respectively. Now, when we look at this, we can consider the value of D in rectangular system, and formula of divergence has x component of D, y component of D, and z component of D to be substituted. So whichever is the coefficient of x vector, ax cap, that will be dx component, and whichever is the coefficient of ay cap, that will be the y component, which should be differentiated with respect to y, and the coefficient of az cap is daisy, and that should be differentiated with respect to z. So let us do it one by one. So divergence of vector D can be represented as del vector dot D, or this can also be written as div D vector. So which is partial differentiation of x component of D with respect to x. So it is 2xyz minus y square plus partial differentiation with respect to y of this term, which is y term, x square z minus 2xy plus partial differentiation with respect to z of z term, that is x square y. And when you look at this differentiation, only x is the variable, the others can be treated as constant. So you'll get 2yz for this differentiation, and here you'll be getting minus 2x, and here it is 0. So the divergence is 2yz minus 2x. This is divergence as the function. Now we need to substitute the value at the point P. At PA with the coordinates 2, 3, minus 1, we can find del dot D by substituting x, y, and z values with respect to the point. So it is 2 into 3 into minus 1 minus 2 into 2. So that gives minus 6 minus 4, which is minus 10. So this is del dot D. And we should also recall del dot D has the unit same as unit of rho v, because this divergence of D vector is giving the volume charge density, which must be given with the unit as coulomb per meter cube. Next, we can do for cylindrical system. For cylindrical system, let us find divergence of D given by this formula. Here, the first term is 1 by rho, dou by dou rho of rho multiplied with this d rho component. So d rho component is rho z square 2 times rho z square sine square phi. So already you have one rho in the formula. So multiplying that will give 2 rho square z square sine square phi. And the second term is 1 by rho dou by dou phi of the phi component of vector z d, that is rho z square sine 2 phi. Then dou by dou z of z component of this vector d, which is 2 rho square z sine square phi. Now we can do the differentiation. 1 by rho, differentiation of this with respect to rho will give 4 rho z square sine square phi. And here for the second term, differentiation is with respect to phi. So rho z square are all constants. Differentiation of sine 2 phi is cos 2 phi multiplied with 2. And the last term has to be differentiated with respect to z. So it is 2 rho square sine square phi. So you will get this row and row getting cancelled, this row and row getting cancelled. We'll be having 4 z square sine square phi plus 2 z square cos 2 phi plus 2 rho square sine square phi. This is del dot D. Now at point PB with the coordinates rho value is 2, phi value is 110 degree, and z value is -1. We can find del dot D. So which is 4 into -1 square into sine square 110 degree plus 2 into -1 square cos 2 into 110 degree, then plus 2 square into sine square 110 degree. We can find this value using calculator and get the answer of del dot D. Solving this in calculator will give us the answer for del dot D at the given point PP as 9.06. So we'll get 9.06, which is the value del dot D, and we must mention the unit for del dot D, same as the unit for volume charge density, which is coulomb per meter cube. Next, we can solve the third subdivision, which is in spherical system of coordinates. So the divergence can be found by taking the formula, which is 1 by r squared 2 pi to r square into r component of D, that is 2 r sine theta cos phi. So I will get 2 r cube sine theta cos phi, and second term is 1 by r sine theta dou pi dou theta sine theta multiplied with the component of d theta, that is r cos theta cos phi. So I'll write r sine theta cos phi, and this 1 by r sine theta dou pi dou phi of this component of phi, which is minus r sine phi. So we can do the differentiation of this. So 1 by r square, and here you'll get 6 r square sine theta cos phi plus 1 by r sine theta dou pi dou theta. I will write the constants first. R cos phi is constant. Now differentiation of sine theta multiplied with cos theta with respect to theta will give, we can do UV rule of differentiation, that is U multiplied with differentiation of V, which is cos theta differentiation is minus sine theta plus differentiation of V, means that is V multiplied with differentiation of U. Differentiation of sine theta is cos theta. So this will be the differentiation of the second term, and the last term is 1 by r sine theta, and here minus r differentiation of sine phi with respect to phi will give cos phi. So whichever is the terms that can be cancelled, we can cancel r, and here finally you'll get 6 sine theta cos phi plus cos phi by sine theta cos square theta minus sine square theta plus cos phi by sine theta. So this is del dot D divergence. Now we can mention the unit as coulomb per meter cube. Next, to find at point PC, where r is 1.5, theta is 30 degree, and phi is 50 degree, we will use calculator and make the substitutions to get del dot D at this point P. Is now when we substitute this in the calculator, we will get the answer as 1.29, and we should also note this is a negative sign, so the answer is 1.29, and We should also mention the unit as coulomb per meter cube. You can practice similar divergence problem for different coordinate systems. Thank you for watching the video.